Good morning, sixth graders. Well, morning to me, could be afternoon to you, could be the weekend, whenever you watch this. Hello, it's Mrs. P here. And believe it or not, this is our last lesson, our last activity that we're going to do in Chapter 8, covering algebra with equations and inequalities. If you recall, we have done writing and solving equations. We have added, we have subtracted them, we have multiplied, we have divided them, we have used fractions in equations. We then moved on to inequalities, where we then discovered how we solve inequalities, how we write inequalities, and today's last lesson is how we graph them on a simple number line. Very easy for you to do, as we realize inequalities were a rather easy concept, probably easier than an equation, because in equations we know you have to have an exact answer. It's a yes or a no. And in an inequality, we discovered through our YouTube video and through our Zooms that we were having, that inequalities have the capability to have numerous solutions, because an inequality is a comparison of one expressional side in an algebraic equation to the other expressional side to the algebraic equation, which then makes an inequality using our comparison symbols in mathematics, which are less than or equal to, greater than and equal to, or maybe it's not equivalent at all, or maybe it's equal to, and then that makes it an equation, of course. So a real simple lesson today, a short video, is our graphing with inequalities. And what we're going to do is we're going to have some inequalities. I'm going to write some down. I'm going to then come up with the possible solutions. And then I'm going to show you how you would graph those on a simple number line. As you see, I have a number line here. I have 3 of them, in fact, because I'm going to do 3 different examples for you. We know already that this is our positive side. This is our negative side. And so whenever we graph, I'll be using numbers over here for my negatives, and over to my right are my positives. I'm not going to write out all the numbers, because then that takes forever, and you don't want me to do that. So I will make markings on the number line, an approximation of where the whole positive number will be, where the whole negative number will be, or in inequalities. And we now know in algebra, in 6th grade math, all these things could also use rational numbers of decimals, fractions, and whole numbers. That is now what we have learned in 6th grade. So I'm going to give us 3 examples, and maybe I'll try to do an example of each one of those, a positive, a negative. Well, then I'll need to make another line. I'll make another number line, a positive, a negative, a fraction, and a decimal, okay? And then that way we can see all the possibilities. So let me first explain to you the largest difference of graphing an inequality compared to just graphing any problem. In an equation or in an expression or any number mathematically, really, not mathematical number, any mathematical statement that you graph, you typically have a definite solution, a definite answer. Or if someone just tells you to graph a number, you have a definite position on a number line where you want to put that. So example, I say, can you please graph me the number 5? You know you're going to come over 1, 2, 3, 4, 5, and say it's in approximately this area. That's graphing the positive number 5. If I said, where's negative 2? You would go 2, 2, 2, 1, 2, negative 2, it's right about here. You would do the same with positive and negative fractions and decimals. It's a positive 1/2. Positive 1/2 between 0 and 1. I'd make a mark. Same if I was doing a negative half over on the negative side. I have 2.5 as a decimal. I would find 1, 2.5, which would be considered a half. So 2.5, I'd mark. That's how we typically graph any kind of whole number, fraction, or decimal on a number line. We find its number position and we mark it with a dot, a point, on the number line. We graph that number on the number line by plotting it, which is saying we're going to put a point on that number line. And we put it directly on the number line. Well, when when you find a solution to an inequality, it's no different. You're going to still find that number of your inequality, and you're going to graph it on a number line. But as we discussed in previous lessons and in conversations during our chats, inequalities can have numerous solutions. So how are you going to graph numerous solutions? As a student, you might be asking, Mrs. P, do you want me to plot points everywhere? I mean, if I can have numerous answers, I can do a lot of different plotting of points on number lines. And there's an actual way in which we can graph inequalities to where you don't have to do that. And that's what I'm going to show you today. So we're going to write down some problems, and I'll probably even try to go ahead. I'm going to go ahead and try to make another number line here. I'll have to move my books and open up the marker. Would be nice too. I'll have to move my books, which is fine. Just forgive me if I'm bending and doing a lot of movement. I'm going to make another number line here. That way I can do a negative, a positive number, a fraction, and a decimal with you, okay? So I have 4 number lines here. I'll see if I can move this back just a little bit further for you. Okay, 4 number lines here. So let's start off with, of course, the greatness of positive numbers, because everybody loves positive numbers. So let me find one that will give us this is a perfect one, a positive number. So the first problem I'm going to do, and I'm going to do it in colors so you can see things here. The first inequality I'm going to do is known as m is less than 15. Okay? So we have a variable here of m. It says its comparison to the number on the right-hand side is that it is less than. That is one of our comparison symbols. Key, know how to read these. Less than, greater than. Watch the way that your less than and greater than symbol is pointing. In this case, it's m, pointing to the m. Our opened area, of course, to the 15, meaning that it's going to expand and continue on, which means that 15 is a greater number. So m must be less than that. Well, if we're just going to use our graphing lines, and remember I said I'm placing them, so it's not rocket science here. This isn't exact. I'm going to say that my number 15 is right here, 15. So if this tells me that m is less than 15, what I need to do in graphing is start at 15. Because I know that my variable is never going to be bigger than 15. So that's where I first want to start my plotting. So in this case, it doesn't say that 15 is included. Remember, if 15 can also be a solution, that will have a line under it that says that m is less than or equal to 15. And this is the big difference in graphing inequalities. My problem said m is less than 15. So that means 15 is not included. So if I want to plot m is less than 15, I want to use an empty plotting point on my number line. That means that 15 is not included in my solutions. Once I put that empty plotting point on my number line, I then just draw an arrow, however far. You can keep going on forever because any number that's to the left-hand side of 15 is less than 15. So here, 6 is less than 15. A negative 3 is less than 15. So anything to the left of my number 15 on the number line would satisfy my solutions for m is less than 15. And since it doesn't say m can be included, I use an empty, open plotting point on my number line. And that's the big difference with graphing inequalities. Now, because I can do that, I can then just draw my line segment down my number line to show every number that could be included. Well, you know, I just said you could go to infinity and beyond, so you do not want to draw on the line forever. Just take the line, put an arrow at the end of it, and that'll let everyone know that I can continue on with other numbers farther than where I stopped, as long as it is less than 15. Hopefully that makes sense. Now, if 15 were to be included, that it says m is less than or equal to 15. If it's equal to 15, then I'm going to fill in my number plotting. I'm going to put that dot in as a solid because it means it's included, like adding it in. It's full. So those are the differences in graphing inequalities. If the number 2, whichever side of my symbol I'm using, greater than or less than, if the number is not included, which means there's no equal equivalency to it, it's left as an empty circle on my graphing number line. If it is, ooh, that's messy. If it is included, I'm going to fill in my circle for my plotting point on my number line. Empty circle means the number is not included. Filled in circle, plotting point, means the number is included. So, for it to be included, you need, I'll make this little note, you need, ooh, that is so messy, sorry. You need to see the equal component. So if you want to have a filled in plotting point on your number line, you better see that equal sign, okay? Equal to, all right? So let's try another one, and then I won't discuss all that information, and then we'll just follow through with the problem, okay? So this was m is less than 15. We then said m is less than or equal to 15, and I showed you the difference of 15 being not included and 15 being included. And so that was with a positive number. Now let's take a look, see if I can find a negative number. Here's one. Use a different marker. X is greater than a negative 4. X is greater than a negative 4. Now, your sixth graders, know how to analyze positive and negative numbers. They know that just because a negative number is larger, meaning it looks larger, that its value is not as good, okay? Its value is not greater. Just because the number looks bigger doesn't mean its value is greater. So in this instance, when we say x is greater than a negative 4, that means that I will need smaller negatives. Why? Because the smaller the negative, the less I am in debt, the less I'm in the hole, the less negative I am on the number line. The closer I am to 0, the better off I am when it comes to negatives. So when this says x is greater than a negative 4, that means I need any number to the right-hand side of negative 4. So I'm going to plot here. This is a negative 4. I'm going to write it above. That's a negative 4. Leave a little space there, Pete. Here's my negative 4 placement. There is no equal sign underneath my greater than. So I'm going to leave an empty hole, an empty plotting point. And I want my extended arrow on my number line to go to the right. Because a negative 3 is actually greater than a negative 4. Even though 3 looks smaller as a number, it has greater value than a negative 4 because the negative 3 is closer to balancing me out at 0. I am not as indebted when I am only $3 in the hole to compare to if I was $4 in the hole. So we've discussed this with your students, so they should have that. So this is x is greater than a negative 4, so x can be anything to the right-hand side of a -4, a -3, 0, a +1, a +2. Of course, 2 is greater than a -4. So that is how we do the graphing of inequalities. I can also do ones with fractions and, of course, ones with decimals. So let me find a decimal here. And then I'll find one with a fraction. Well, the fraction's going to come first, of course. So it says A is less than 2/3. Now, unless a number line is broke out for you exactly in the equivalent parts, so unless every number line is broke out into thirds, again, this isn't rocket science. The kids can just place them on there to the best of their ability to where they think it's located. And of course, I looked at the time and I'm already at 16 minutes. Oh, Mrs. P, you're grand. So this says that A is less than 2/3. So for me to graph this, I would first need to find 1. Here's 1. I would need to know that 1 is broke up into thirds, because this isn't a whole. This is just parts of a whole, 2/3 out of a whole. So I'm going to break my 1 into parts of 3. 1/3, 2/3, 3/3 would give me 1. I'm going to mark 2/3. I'm going to leave it open again because it doesn't say that it's included, doesn't say it's equal, and A has to be less than that. So my line is going to go to the left because anything to the left would be less than 2/3. If I went to 1/3, it's less than 2/3. If I was at 0, it's less than 2/3. If I was at -1, it's less than 2/3. Now, the only difference again is if it says equal to, instead of leaving an empty circle, I'm going to fill it in, and that way I know that 2/3 could also be a solution. Last one, a decimal, and I'll just make one up here and I won't look, and I'll lay these down. Let's say J is greater than 2.5. So what this is stating is that whatever is over here has got to be greater than 2.5. Again, I'm just going to find my number placement. 1, 2, 3. I want to make that a 2. 1, 2, 3. 2.5 is equivalent to 2.5. I'll break that up into halves. Oops, sunlight there. I'll break that up into half. I'll then say 2.5 is located here, and I need anything greater, so I'm going to go out to my right and extend my line with my arrow. If it had said equal, I would then just fill in the circle. All right, so that is graphing inequalities on a number line. Eventually, at some point in life, this year or not, we will graph these on graphing grids as well, where there are 4 quadrants, which we've already discussed with the students, of positives and negatives together in quadrants on a graphing grid. So, graphing with inequalities, watching our comparison symbols that we used in mathematics, whether it's greater than or less than, know how to read those inequalities, find those numbers on our number lines, decide which direction do we want to go, greater than or less than compared to that number, plot that number on our number line for our variable, and decide whether it's included or not included. Included is filled in, not included is not filled in, or not filled in, it's not included. And then our arrow goes to the left or right on the number line with an arrow at the end of it saying it can extend on, showing all the possible solutions for an inequality. And that's it. And by the time I push the button, hopefully it'll say 20 minutes and we'll be done. If you have any questions, kiddos, just email me, talk to me. I hope you have a happy Easter. It's coming up this weekend, as always. I miss you guys. Enjoy. I hope the Easter Bunny at least brings you a sweet treat because you're a West Platte Blue Jay and you deserve it. Miss P loves you.